In this video, we're going to talk about how to make the velocity time graph and the acceleration time graph from the position time graph. So these x-graphs are the position time graphs, and I'm just going to do number 4 and number 7 from this worksheet, and then you're going to do the rest. So if you look at this curve on number 4, you can tell that it starts off with a really flat slope. So if you, let's pick a point near the beginning of the graph, and if you notice, you could take the slope of a tangent line at that point, and that would represent the velocity at that point. So we don't care really where this graph starts, what position it starts at. When we make the velocity time graph, all we care about is what the slope is at that point, okay? So here it looks like it basically has a velocity of 0 because the slope is 0. So what I like to do is just graph what the slope was at the beginning. And then when I check the slope later on, okay, like maybe at this point, it is much steeper, and has like a negative slope to it. So then if I kind of take that time down here, okay, then I would be plotting the slope, and I don't know a number, so I'm just going to pick like some negative number, because I know the slope is some negative number at that time. And then I am guaranteeing you that any curves on this on the position time graph are quadratic, okay? And when I argue that, then I am basically guaranteeing you that the velocity time graphs for those position time graphs have to be linear, and there's calculus to prove that, but this is not a physics with calculus class, okay? So because of that rule that quadratic position time graphs go with linear velocity time graphs, then I'm going to connect my two dots here with a line, okay, that slopes down. And that shows, right, that the velocity is decreasing on a number line as time goes by. The slope is getting more and more negative on my velocity time graph. And then, what do I do to get the acceleration time graph? Well, I need the slope of the velocity time graph. So then I would take like a certain point, I would look at the slope of this graph. I would take another point, and I would look at the slope later on. But since the velocity time graph is linear, then I know that slope is not going to change as time goes by. And it's negative in this case, right? So it's just a constant, like, I don't know, it could be -2. I just don't have any numbers, but I know that it's negative and it's not changing, and so I would just draw a line below the x-axis. Okay. Let's do number 7 here. That one's kind of weird. It's like a combination of like the right side of a parabola and then a line on the position time frame. Okay, so if I look at the beginning of this, again, it starts off kind of flat. If I take the slope of a tangent line, so that would mean that the slope at the beginning is 0, which means that the velocity is going to be 0 at that moment, okay? And then I check later on, and I draw a tangent line, okay? And I have a very high slope, positive. So maybe I draw, a very nice high positive number representing the velocity of that object at that time. And then we said, because it's quadratic on position versus time, it's got to be linear on velocity versus time. So I'm drawing a line between those 2 points. Okay, I'm going to erase this to take the distraction out. Now notice though, when the dashed line comes, then suddenly the slope becomes less, you know. It was really steep at the end of that parabola, and then it kind of just drops off and becomes linear and constant. So like the slope right here and the slope right there are the same, and they're less than it was right there. So then I'm going to have like a discontinuity. Maybe your math teacher would have put it like an open circle or something here. I'm not going to be too picky about that, but I'm going to draw some other lower velocity that is not changing. This is supposed to be a flat line here. Okay. And then to make the acceleration graph, I'm looking at the slope again, but this time of the velocity graph. So I'm checking the slope at the beginning, I'm checking the slope later on. So for the first part, looks like some positive number that's not changing. So I would put some positive number here above the x-axis not changing. Then after the dashed line, I take the slope of this part. Well, slope of that flat line is 0, right? So then I would just put it on the x-axis here. Okay. Hope that helps you with the rest of the worksheet.